Now, how does natural gas form? It's formed in marine environments for the most part, so oceans, okay, in the deeper waters. So what you find is you have the land here, and there are various plants and organisms that die and get washed off into the water. As you get farther and farther away from land, the grain size, the sediment that's coming from the land, gets smaller and smaller. So the really heavy stuff, the bigger particles, get dropped close to land. So that's why you have sandy beaches, right? Because the sand does not get moved as far. The lighter particles, the smaller particles, sand, silt-sized, and clay-sized particles will float in the ocean, stay in the water for quite a long time, and so they get farther and farther away from shore. So if you get way out here, you have finer grained material dropping down to the bottom of the ocean. Along with that is various types of organic debris from land, plant materials, algae that's living in the surface ocean. When it dies, it drops down to the bottom and accumulates on the bottom. Now that alone is not enough to produce oil or coal or petroleum. You have to have certain conditions, and one of them is an anoxic environment. An anoxic environment is where there's no oxygen. It can't even be really low oxygen. It has to be no oxygen. This means that the organic matter that accumulates on the ocean floor stays there. It doesn't break down. The more you get, the better. All right, so you get a lot of organic material building up out here in the deep ocean with a lot of silt-sized material or mud-sized material, and it gets covered. So you have a layer of organic material, then a lot of sediment, various pieces of mud and debris from land, buries it, and over time it gets buried deeper and deeper. So here's a nice organic layer here, covered by layers and layers of sediment. The material that is closer to land is this type. So again, it can be cobbles. This is actually cobbles, or it can be sand-sized particles. Okay, so your beach particles that you see on the beaches, in stream banks, and so forth, are these larger particles. So these are the ones that are close to shore. The farther you get out, the finer the material. I'm going to pass these around in a few minutes, just not yet. So here's a little bit finer grained, and then we get very fine grained. So you think about mud puddles, where they're very fine grained material in them, versus a beach sediment. Material's dropping and slowly accumulating out here. No oxygen. That doesn't happen everywhere. This is an unusual circumstance. Okay, so to have, if you go out into the deep ocean today, there's oxygen out there. So it has to be a very special case where there's no oxygen at all. Very low circulation of the water, just the right circumstances. And that's why it's so hard to find natural gas and petroleum and so forth, because it's not formed everywhere. And it takes a long time. The Marcellus Shale is over 385 million years old. So it's been sitting down there for a long time, accumulating and developing. Now, as it's buried and more material is put on top of it, as the material is dropping down to the bottom, it's not just good stuff, right? It's not just little mud particles and so forth. There are other things dropping down at the same time. Anything that's washing off the land can end up out in this area out here. And that includes nuclear material, radioactive things, iron, chromium, arsenic. Anything that's washing off the land can end up out in this deeper ocean. Now, even 385 million years ago, you had those types of things getting out into the ocean because the rocks that you see on the land have those in them. Okay, we have mercury, arsenic, radioactive materials, uranium, and so forth are in the rocks on land in small quantities. They wash off, they get out into the open ocean, and then they settle. It turns out that the clay particles, these very tiny particles that end up settling way out into the deep ocean, tend to attach or attract these particles. So they'll attract radioactive material. They'll attract iron, various things. So as the material is starting to form and start to form into a rock, it's these pieces of extra minerals and so forth are attaching to the clay particles, and they're staying in the rock. Okay, they're concentrating. Okay, so over time, more and more material sits on top, and the layers down towards the bottom have a lot of pressure on them from all this weight above it, and they start to do two things. One, they start to dewater. which means that the water that's in the layers starts to come out because of the pressure above it. So that it's being pressed down, pressed down, pressed down, water's being pushed out, and it starts to change from a sediment to a rock. This takes a long time. Now, that's not enough. Then you have to add heat to the system. And that typically happens the more deeper you get into the ground, the more weight that's put on top, the warmer it gets. The closer you get to maybe magma sources and things like that, the hotter it gets. And so you have to actually hit a particular temperature. Now, if you go too high, you'll cook off any organic matter and you lose everything. All right? No coal, no natural gas, no oil. If you go too low, you might get oil. If you go, there are different temperatures. So one temperature, you'll get oil. The next temperature, you'll get oil and gas. The next temperature, you'll get just gas. You go too high, you get nothing. All right, so it's a very special system. You're still not done, because while this is buried down there, it's turning into oil, it's turning into gas. It can escape. So it needs to be trapped in some way. If it doesn't have some way to be trapped, and that's why I added this salt dome here. So this is salt that's moving up to the surface slowly over time. And here's some organic material that's maybe on its way to being oil or gas. And it would normally just sort of travel on through here, maybe spread out over the area. But as it's moving along, it hits this salt dome and becomes trapped. And now you have a place where you can find this material. Okay, that's the normal way we look for gas. We look for traps. We look for faults. We look for salt domes and other physical traps that hold the oil or the gas in place and keep it from traveling away. If there are no traps, it just spreads out. It escapes somewhere, maybe gets up to the surface and escapes into the atmosphere, and you lose it. So all of these deposits that you find, oil, natural gas, coal, the process that's involved in getting to that point and actually having something that you can actually extract from the ground, it's a huge amount of special circumstances that have to occur in order for you to find anything usable.